Solve each equation by using the square root property or completing the square. To begin this equation, the first thing we need to do is to write it in standard form. So we need to move this negative 8x to the left-hand side. So I'm going to add 8x to both sides. So I end up with 2x squared plus 8x minus 3 equal to 0. Now when we're completing the square, we need to look at the coefficient for the variable that's being squared. That always has to equal to 1. So in this case, we have a 2. So to get rid of this 2, I'm going to take and divide each term by 2. We end up with x squared plus 4x minus 3/2 is equal to 0. The next step is to leave the variables on one side and move the constant to the right-hand side. So I'm going to add 3/2 to both sides. So we get x squared plus 4x is equal to 3/2. To complete the square, what we need to do is we need to take the coefficient for the middle term, which in this case is equal to 4. We always divide it by 2. So we're always taking the coefficient for the middle term and divide it by 2, and we get 2. And then we take that 2 and we square it to get 4. So this 4 here is what we need to add here so we can complete the square. So this trinomial here becomes a perfect square trinomial. But we just can't add 4 to one side, so we just have to add 4 to the other side so we can maintain the equality of our equation. Now, when we factor this, we're looking for two numbers that add up to 4 and multiply to 4. You can see that we have 2 and 2, so we can write this as x plus 2 squared. Or whatever number you get here, that's the number that goes there. And this is going to equal to 3/2 plus 4, which is equal to 11/2. So I'm taking the 3/2 and adding 4 over 1. Find the common denominator, that's 8 plus 3, that gives us 11/2. Now we need to use the square root properties. Remember the square root property, we have something square on one side is equal to a constant on the other side. To solve, we just have to take the square root of both sides. So we get x is equal to either the square root of k or x is equal to the negative square root of k. So I'm going to take the square root of both sides, and I end up with x plus 2 on the left-hand side. When we take the square root of something that's squared, we undo what's being done, so we're just left with what's inside the radical. And then that's equal to plus minus, because we have the principal and the negative root, 11 square root of 2, and it's the square root of that. Sorry, 11/2 and the square root of that. Now I want to know x by itself, so I'm going to subtract 2 from both sides. So we get x is equal to negative 2 plus minus the square root of 11/2. Now we would almost be done, but remember one of the conditions for a radical to be simplified is that we don't have any fractions in the radicand. So I'm actually going to use the quotient rule to separate this, and we get the square root of 11 over the square root of 2. Now it's still not simplified because we have a square root symbol in the denominator. So we need to rationalize the denominator by, or in other words, get rid of the square root 2. So what I'm going to do is I'm going to multiply this by the square root of 2 over the square root of 2. Because now when I multiply the top, I'm going to get the square root of 22. And when I multiply the bottom, I'm going to get the square root of 4, which simplifies to 2. So now we have x is equal to negative 2 plus minus the square root of 22 over 2. And then we're still not done with this problem, because when we're writing this problem, we have to write a common denominator for these. So we need to write it as a single number here. So we have negative 2 plus minus the square root of 22 over 2. So we need to find the common denominator, which is 2. So this is just going to be the square root of 22, so plus minus the square root of 22. And here we need to multiply that times 2, so we get negative 4. So then our final answer is x is equal to negative 4 plus minus the square root of 22 all over 2. So remember, we can't leave it as a separate numbers here. We have to combine them, so we have to find the common denominators and then add the numerators and put it over the denominator. So this is our final answer.